Hello, this is Geometry, Chapter 1, Section 4, Measuring Angles. So we have one array here. We'll call that AC. And we have another array here. We call it AB. And we'll say that an angle and we use this form, the symbol for angle, is formed by two rays with a common endpoint. Or the book says the same endpoint, with the same endpoint. An angle is formed by two rays with the same endpoint. So in this case, the same endpoint would be this guy, A. But we don't call them endpoints when we're discussing rays. We'll call it the vertex. We'll call it the vertex. And what the vertex is, according to the book, vertex is the endpoint of an angle. So instead of calling it an endpoint, we call it a vertex. And when they share the same vertex, we call it an angle, when they share the same vertex. Now, an angle is comprised of two sides. So this would be a side, and this would be a side of an angle. So AB would be a side of an angle, and AC would be a side of an angle. So a side of an angle would be the rays of an angle. The rays of an angle would be the side of the angle. So since there's two rays, there's two sides. The book talks of interior, exterior. So we have an angle comprised of two rays, which are called two sides. They share a common endpoint, which is called the vertex. Everything in between the two rays, all the points in between the two rays, is called the interior. So remember, these things go on forever. So this whole thing in here would be the interior of the ray. Everything, all the points that are outside of the rays is called the exterior. All of this on the outside of the rays would be the exterior of the rays. Interior, exterior of the rays. Alright, there's a lot of ways to name rays. We have this situation here. We have M here, the vertex. We have L up here. We have K up here. We have J up here. And we have some numbers here inside in the interior of the rays. Okay, so we can call it a lot of stuff. So we have the part with the number 1. According to the book, we can call number 1, we can call it angle 1. We can call it angle JMK. We can also call it angle KMJ. Remember that the vertex is always in the middle. For angle 2, we can call it angle 2. We can call it angle KML, and we can call it angle LMK. We can call it those. So there's 3 ways to name each angle according to this particular picture. Remember that we can't call it angle M. We can't call it angle M because remember, M could be referring to JMK or M could be referring to KML. We don't know which. We don't have enough information. So since we don't have enough information, we cannot call it angle M. Protractor postulate. What the protractor postulate says is that consider ray OB at point A and a point A on one side OB. Every ray from OA can be paired with one real number from 0 to 180. So using a protractor goes from 0 to 180, a straight line. And if we have an array OA, which is in red, paired off with array OB, which is paired off in blue here on this picture, what this is just saying is that this ray in red is going to hit a number such that it is between 0 and 180, meaning it's going to be some number on the protractor. Since the blue ray is going to the right, we start with this 0, whatever 0 that is, and we measure it up here, and it is 125 degrees. Here it says using a protractor postulate you can get the measure of an angle, and you can get the measure of an angle by in this case it's angle COD by subtracting its degrees on the protractor. So remember, if we're starting with the blue, that would be gross, ugly numbers. So you just subtract the 2 difference of the numbers. Okay, so we have 4 types of angles. We have an acute angle. Here's an example of an acute angle. An acute angle is an angle that is between 0 and 90 degrees. An acute angle is between 0 and 90 degrees. We have a right angle. And a right angle is exactly 90 degrees. Exactly 90 degrees. We have the little box symbol between here that tells me it's 90 degrees or right angle. We also have a obtuse angle. And an obtuse angle is an angle that is between 90 degrees and 180 degrees. And then we have straight angle. And a straight angle is an angle that's exactly 180 degrees. And a straight angle will always be in the form of a straight line. It will be called, it is a straight line. Okay. It says, what are the measurements of LKH and HKN and MKN? Classify each angle as a cube of two straight. Okay, so if we were to use this protractor, it asks me what is the measurement of LKH. So this is LKH to the left. Since it's using ray HK, I'm going to start with 0 right here. So I look at the measurement, I could go from 0, and I'm using the outside set of numbers, and it stops at 35. So LKH, the measure of angle LKH is 35 degrees. Since it's between 0 and 90, it is acute. Then they ask HKN. 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 And notice it forms a straight line, so it is a straight angle. We know that a straight angle is 180 degrees. So the measure of angle HKN is 180 degrees. Therefore, it is a straight angle. Then they ask for MKH, MKH, MKH. So you look at the H, go all the way over here, and it stops at 145. So the measure of angle MKH equals 135 degrees. And since it's between 90 and 180, it is an obtuse angle. Obtuse angle. Okay. Congruency and equality. When we have two angles, we'll call this angle A. We'll call this angle B. When we talk about the numeric value, we would say that it's the measure. So the measure of angle A, right, we would say a measure of angle A is like 30 degrees, right? Well, since I know that they're the same, I can also say that the measure of angle B equals 30 degrees. Notice that I use the equal sign because it equals some numeric value. So when I talk about equality in terms of the measurement, I can say the measure of angle A is equal to the measure of angle B. If I know that two things are equal, then those two things are congruent. So I can say that the angle A is congruent to angle B. I don't have to say the measure. Measurement prescribes to a particular number, and if I'm measuring their angles, or degrees rather, since I'm measuring it for a number or a degree, then I can use equal. If I'm talking about congruency, I'm just talking about the size and shape of the angle. I'm not talking about the number itself, what it measures. And since I'm talking about size and shape with congruency, then I can use the congruent symbol, and I don't have to worry about what actual degree it is. If something is equal, then something is congruent. If something is congruent, then something is equal. Alright, so let's use a photo in problem 3. The measure of 49 of ABC is 49 degrees. What is the measure of DEF? Alright, so I have ABC over here, and I'm told that ABC equals 49 degrees. They want to know what DEF is. So notice that DEF has one tick here. So if I was to draw the angles ABC looks like this. Angle DEF looks like this. I have a marking over here. I have a marking over here. Since they have the same marking, I know that they're congruent because they have one marking. So I can say that angle CBA is congruent to angle DEF because they have the same marking. That tells me that they're congruent. Since they are congruent, I know that they're equal. So I know that the measure of angle ABC is equal to the measure of angle DEF, which equals 49 degrees. So DEF equals 49 degrees. Angle addition postulate. What the angle addition postulate says is that if I have two rays that shares, or two angles that shares a common endpoint, they would say that B is in the interior of A and C, of angle AOC. So I have this angle here, and I have the red angle here. I can say that angle AOC the big angle is equal to the sum of the smaller angles. So angle AOB plus angle BOC. I add the two smaller angles up, it's going to give me the bigger angle, and this is the angle addition postulate. I'm going to write, just going to say add. Angle addition postulate. POS for postulate, add for addition. Alright, now when I can use the angle addition postulate, I can do a couple of things. So for question number 4, example number 4, they give me an angle comprised of two smaller angles, and I have a C, E, F, and I have D. I'm told that that angle is 11x minus 12. I'm told this angle is 2x plus 10 degrees. So I'm told that the whole big angle, angle DEF, is straight. So if it's straight, I know that it equals 180 degrees. So if I use the angle addition postulate, I know that angle DE, actually before I get there, I also know that I have these two smaller angles, and I have angle DEC, and that's equal to 11x minus 12, and I have angle CEF, that's equal to 2x plus 10. I also have the overall angle DEF, and that's equal to, using the angle addition postulate, is equal to DEC plus angle CEF equal to angle DEC plus angle CEF. So I'm going to substitute 180 for DEF using the angle addition postulate. I'm going to substitute 11x minus 12 for DEC, and I'm going to substitute 2x plus 10 for CEF. So now instead of DEF equals DEC plus CEF, I have 180 equals 11x minus 12 plus 10. I'm going to combine like terms. I have 180 equal to 13x minus 2 okay, and I get 182 equal to 13x. I'm added 2x to both sides, and then I get by dividing by 13, I get 182 divided by 13 is 14. So x equals 14. Really? Okay, so x equals 14. But that's not what they want. Now that we have that x equals 14, I can solve for the two angles. So I can say for DEC equals 11 times 14 minus 12. So 11 times 14 is 154 minus 12 is 142. So angle DEC equals 142 degrees. And then angle CEF equals 2 times 14 plus 10. So 2 times 14 is 28 plus 10 equals 38. So angle CEF equals 38 degrees. And then if I add 38 plus 142, that's going to equal 180 degrees, which is a straight angle, so I know that it's correct. Alright, so that's this section. Hope you have a great rest of your day.